This is a question involving equations involving indices. Some persons they find it difficult to find solution to this question or to understand how to solve equations involving indices. Now this question is peculiar because it says 3 raised to power y is equal to y raised to power 9. So here, at the left-hand side of the equation, you have the base raised to power y. At the right-hand side of the equation, you have the base y raised to power 9. There are two methods we can use to solve this question. So let's go straight to this method. The first method involving taking the inverse of the powers. If I take the inverse of the power here, it's going to be 1 over y. I take the inverse of the power of the right-hand side of the equation, it's going to be 1 over 9. I'll multiply both together. If I do that, I'm going to have 1 over 9y. The next step is to multiply each of the powers of the equation by 1 over 9y. So this will be 3 raised to power y and brackets raised to power 1 over 9y equal to y raised to power 9 and brackets 1 divide 9y. If I simplify, this will go and this will cancel out. I'll be left with 3 raised to power 1 over 9 equal to y raised to power 1 over y. Now what I've succeeded in doing is to put the letters on one side of the equation and the numbers on another side of the equation. Now this is very important. The next thing I will do is to express the left-hand side of the equation, 3 raised to power 1 over 9, to look like the right-hand side of the equation, which is y raised to power 1 over y. And notice in the right-hand side of the equation, the base is y, and is raised to power 1 divide y. But at the left-hand side of the equation, the base is 3, and is raised to power 1 over 9. So what's the point? Here the base is y, here this is y. So let's also make the base the same with the number here. This is 3, this is 9. So how do we make it to be the same? I'm going to do something like this. I will express 3 to a power, which is raised to power 3, and multiply the denominator of the power by the same 3. This way, it will give me what I'm looking for. 3 raised to power 3 is 27, or raised to power 1 divided 3 times 9, 27. And this is equal to y raised to power 1 over y. So we could see that the left-hand side of the equation now looks like the right-hand side of the equation. I chose to use 3 because that's what will give me what I'm looking for. If I had used 2, it's going to be 3 raised to power 2, which is 9. And remember, you're still going to multiply this by the same 2. And that will be 18. So it will not give you what you're looking for. Now, it's important we multiply both this and this by 3 because if you divide, it will give you back your term that you have here. So I can multiply this by 2 and multiply this by 3. No, I must multiply this by 3, 3. Neither can I use 2 because if I use 2, 2, this will become 18 and this will be 9, so it won't give me what I'm looking for. So at this point, the next thing we do is to equate the powers. You either equate the powers or you equate the base. If I equate the powers, it's going to be 1 over 27 equal to 1 over y. If you cross multiply, y will be equal to 27. So this is what we're looking for. If I decide to equate the base, it will be 27 equal to y. So therefore, y equals to 27. So each of them, anyone you decide to do, give you the same result. Either you equate the powers or you equate the base. So y is equal to 27. Now, if you check the solution to this question, you will get what you're looking for, which means, let's check. Use your calculator. 3 raised to power 27 is the same value as 27 raised to power 9. Whatever you get here will also be the same here. Another way you can check using indices is to say 3 raised to power 27, which is your left-hand side, is equals to, you can express these in indices, which is 3 raised to power 3, and then 9. 3 times 9 will give you 3 raised to power 27. So that shows that your solution to the question, it's correct. So y is 27. Now I'm going to show you the second method we can use to solve this same equation. 3 raised to power y is equals to y raised to power 9. Now, what is the second method? The second method involves the use of logarithm. So I'm going to take the logarithm of both sides. So it's going to be log 3 raised to power y is equal to log y raised to power 9. Now, the laws of in logarithm shows that you can bring the y to the side of the log so that you have this y log 3 equal to the same thing to your right hand side, 9 log y. Now, what I have here is actually in log 10. But if I check, you'll notice that the base here is 3. So I can decide to introduce base 3 to the logarithm instead of base 10. That way, it becomes easier for me to solve. So I have taken it from base 10 to base 3. If I do it that way, log 3 to base 3, it's 1 from the laws of logarithm. If you have log 3 to base 3 is equal to 1. Log 10 to base 10 is 1. Log 5 to base 5 is 1. So in this case, this log 3 to base 3 is equal to 1. So I will left with y here equal to 9 log y to base 3. How do I take away this logarithm from the right-hand side of the equation? Is to use the base to take up the y to its power, and this becomes 9y. Now at this point, you have 3 raised to power y equal to 9y. So we can use the, is it the try and error method or substitution method? If y is equal to 1, then this will be 3 raised to power 1 equal to 9 multiply 1, which will give you 3 equal to 9. And that is not what we're looking for. If we decide to use y equal to 2, this will give us 3 raised to power 2 equal to 9 multiply 2 in place of the y. That will be 9 equal to 18. And again, this is not what we're looking for because 9 is not equal to 18. If I decide to use y, if y equals to 3, I'm going to have 3 raised to power 3 equal to 9 multiply 3. 3 raised to power 3 is 27. 9 times 3 is 27. So this is what we're looking for. So here we can say the value of y is equal to 3. So in the equation, that is your solution. So either method can be used. The first method, if that's the one you understand, fine, feel free to use it. But if it is the second method, you are also good to go. Indices, logarithm, and surd goes together. Now this is a question involving surd. Here the question wants us to simplify. Now what we'll do is to reduce each of the term into a simplest form. Root 27 will become 9 multiply 3, that's 27, plus root 32 becomes 16 multiply 2. Now, when you do this, ensure that one of the number is a perfect square. So 9 is a perfect square, 16 is also a perfect square. So when you look for how to get the two numbers to multiply to get back the number, always remember that one of the number must be a perfect square, while the other number will be a prime number. That's where you are correct, because you can be able to get the square root of the one of the numbers and then express the other in a rational number. Um, express it as a surd. Then for root 18, this will be 9 multiplied 2. So we have succeeded in getting one of the numbers to be a perfect square, the other to be a prime number, perfect square, a prime number, perfect square, a prime number, and they will give us back what we had there. The square root of 9 is 3, but we cannot get the square root of 3, so we'll write back the square root 3 plus square root of 16 is 4, but we cannot get the square root of 2, so we have to write it back. Divide the square root of 9, 3, but we cannot get the square root of 2, so we have to write back. So at this point, we are not done with the solution. If you look at your denominator, you notice that you still have surd there, so an irrational number. So what we have to do is to leave our solution as a rational number, which means there should be no square root at the denominator part of the question. So what do? I'm going to multiply both the numerator and the denominator by what I have here in the denominator, which is 3 root 2. If I do that, I'm going to have 3 root 2, I'm multiplying this, and I'm also multiplying this by 3 root 2. So remember, whatever you do to the numerator, you must do it to the denominator. So let's multiply. This can only multiply this to be 9, and the root will multiply what is also in there to be 6. So 3 times 3, 9, root 2 times root 3 is root 6. Plus 3 times 4, 12, root 2 times root 2 is root 4. Divide 3 times 3, it's 9. Root 2 times root 2, that gives you root 4. So this will be 9 root 6 plus 12. Now you can get the square root of 4. Square root of 4 is 2. So you multiply by 2. Divide 9. You can also get the square root of 4. So 9 multiply 2. So final answer will be 9 root 6 plus 2 times 12 is 24. Divide 9 times 2, 18. Again, we can this simplify further. So the highest common factor here, it's 3. And if you factorize this, you're going to get 3, you open brackets, 3 root 6 plus 8, divide 18. And if this 3 should cancel out, so your final answer will be 3 root 6 plus 8 divide 6. That's what we're looking for. So that's how you solve questions involving surd. Thanks for watching. Remember to subscribe to my YouTube channel And if you have any question, use the comment section. If there's a topic you want me to teach, please also put it there. See you in the next video.